We can begin?
Yeah, we can begin.
Yeah, I think so.
Well, if everyone has their food, then I guess we can start. So, welcome to the first lunch and learn. I mean, it's a nice occasion, right? So, today I will be talking a bit about AI for software development. So, should I do a step to the side? Or I'm like moving away, and I'm like, oh no, I need to make sure that I'm still in the frame. Today I will be talking to you about AI for software development, and what that means is basically giving you a crash course on how it's different compared to what you do on a daily, basically. So I will walk you through what traditional programming is, which you're probably familiar with, and how it differs. I will talk a little bit about bias, which is a very important topic when you talk about AI. And I will give you some tips for when you're working on a project where AI is involved. And we will finish off with like a nice question around it. So to start off, how AI is different from traditional programming. So you probably all have like this notion of this all-knowing machine that is called AI, I guess. So let me just give you a quick idea about how it compares to traditional programming. So basically what you're doing when you're developing software is obviously writing rules. So you have some kind of data, you act on it with your rules, and then you get an answer out of it. So let's just say you are calculating some financial statistics. So you have a price that you get from a database, you get the earnings, and then you do some kind of calculation on it. It's a very clear rule-based system where you get an answer at the end. So basically you can express it as rules that you get, you have data, you do something with it, and you get answers back. So what is different here is that for every scenario that you're working on for traditional software development, is that you need to have these rules predefined. And you're quite limited in the scope of the things you can do, obviously, when you rely on these defined rules. So most of the times, if it gets too complex, it's just infeasible to start writing traditional code for it, because it's just not how life works, I guess. So then obviously, does machine learning look at that? So let me give you an example. So let's just say I want to create a fitness tracker. I'm only measuring speed at the moment. So what I'm just going to do is, okay, if my speed is, if I'm moving, basically I'm walking. So my status is walking. Well, then you can figure out if you want to add running to it, what would you do? No?
Higher speed.
Yeah, exactly. Higher speed, and then you're running. So let's say below 4 I'm walking, above that I'm running. So then you're like, okay, sure, but what if I also want to add biking? Well, then you just, I guess, add another speed bar. But then the question is, what if I'm wild and I want to also include golfing? I mean, then you kind of rub against the boundaries of what you can do here, because how are you going to add some kind of rule-based system in for recognizing that you're playing golf at the moment? So there machine learning comes in, because basically if you look back at a traditional programming thing, you have rules and data and you get answers from it. You flip it around in machine learning basically because you don't know the rules, you want to get to know the rules. So what you do is, instead of putting in your rules and data and get answers back, you put in the answers and the data and you get rules back. And with those rules you can, for example, create patterns to see if you're golfing or running or walking. So basically what that means is, I have this nice fitness tracker over here, which tracks, well, I don't know, probably Nick can tell you more about that, what the Oura Ring tracks. But things like body temperature, speed, GPS, height, stuff like that. And you get these patterns from it. Basically, what that means is that you have this weird pattern of all the data that you've collected, and you attach a label to it. So if your fitness tracker observes this pattern of data, it will think that it's walking because you've trained your algorithm to recognize that this pattern of statistics regarding your heart rate or your temperature ends in you walking, because it has a historical pattern of walking there. And this way you can extend your fitness tracker indefinitely and get yourself a system that doesn't look at these specific rules, but figures out rules on the go, depending on the data that you put in. Which means that you get these nice little interface pieces where it recognizes after a while that you're cycling when you're doing something, when your heart rate spikes up or something like that. So, to conclude here, when you work with machine learning, basically your job changes from figuring out the rules, so the rules that you would put in a software program, to determining activities. So, what kind of label could you attach to this data? The code that you then write, like a Python machine learning code, then matches that data to activities. So instead of the rules that you don't know the rules beforehand, and you just go ahead and tell the computer to figure it out for you, basically. So then there's a lot of things that come that come by as a problem here. Because obviously your whole mindset and perspective changes when you work with machine learning. One of these things, I cannot tell you all the details obviously, because then not that I'm busy for 10 minutes or so, but otherwise I could go on for hours. But one of the things I felt like was important to talk to you about is bias. So if we go back to our example of the running, and let's just say that your data that you've collected is all about men running. But unfortunately for you, you are actually not a man. That means that you have created an algorithm, but maybe your heart rate is different because you're a woman, or your temperature handles differently. That means that the algorithm might not be able to predict accurately if you're running or not. And that is not necessarily a groundbreaking issue in this example, but what if the same counts for algorithms that detect whether you need additional healthcare, or algorithms that might be used, well, in the US, for example, that are used for determining whether you might commit crimes again. Or when you're applying for a job and you're not a white man, so you don't get a chance to be interviewed. So these are all very apparent issues that you have when you don't necessarily control the rules, but you let the rules be defined by your algorithm. So that issue is called bias. So there's this, you have collected data of a very uniform group, and then out in the world you see some other people, and obviously you collect data on them, and it does not go the right way. So issues could be discrimination or other social consequences that happen when you don't take into account that what your algorithm can actually do for you is bad. So the issue is that it's pretty hard to deal with. So because machine learning algorithms are designed in a quite complex way, it's also quite hard to explain the decisions that are being made. So you can't really track from what you see in the data to the outcomes of the rules, basically. At least in most machine learning algorithms, it's very hard to do. And as a result, the bias in algorithms are often undetected, or not immediately detected until you start using it in production and you find these weird edge cases that you did not expect in the data yourself. So yeah, what you can do about it, there's lots of research going on to make AI algorithms more explainable, so that you can actually see why someone is labeled a certain way. For example, in financial institutions, it's very important to do, obviously, when you get credit examinations, stuff like that. But it's still very early, especially now that models get bigger and bigger, and it's actually harder to see where all the data is coming from and see what influences decision making. So yeah, this is kind of the hard point of it all. If you're working with a system that includes machine learning, basically everyone is responsible for seeing those bias issues and examining your software to see if there's anything weird going on. So if there's one message you take away from what I'm talking to you about today, is that if you see something that might influence a certain group of people in a better or worse way, it is also partly your responsibility to acknowledge that and come forward about it. Well, so that is a nice bridge into my 5 top tips for dealing with an AI component. So if you're working on a project with me, you know what you can expect, basically. So tip number 1, test everything except the generated output itself. So how machine learning generally works is that you don't know what the outcome is going to be if you run the cases repeatedly. So if you put in exactly the same data, because the networks are generally randomly initiated, you will always get a different answer. And it could vary slightly, but it could also vary quite heavily, I can tell you that. So always test everything around the answers. So check if the, I don't know, data type that is returned is like what you expect it to be, or test the interface elements and stuff like that. But the generated output itself is quite hard to test, so I would not advise to go and test that. Then allow for inaccuracies. So obviously machine learning is also never 100% correct, which means that there's a lot of edge cases that you need to deal with. Things that can go wrong probably go wrong. So you need to have fallbacks in place for that if something like that happens. And then tip number 3, record outputs, inputs, and everything in between. This comes a bit back to the bias issue. If I release an AI model with an endpoint to you, I generally don't know what will be the input and what will be the output. I just give you the results, which means that it's very hard to track if something goes wrong, if things go to in a different way. There's been lots of talk of AI models that are incredibly racist, so those are the issues that you can expect. So inputs and outputs tracking is very important. And next to that, everything that goes into a model or everything that is being observed on platforms that you're working on could be used to fuel new AI models. So I always recommend tracking as much data as possible, because we might be able to do something with it for our customers. Then number 4, make sure that the people from the companies that we work for actually know what is going on, obviously. AI is kind of an expectation management game most of the times. So if there's weird outcomes, if things don't happen as expected, most of the times it's just a tiny issue that needs to be fixed, but it's something to, if we sell an AI system, I try to always tell the customers that some stuff that it's not a certain system, so things can go wrong and can get some unexpected results, and customers should obviously know about that. And the final tip, report weirdness. Again, goes back to the bias element. If something is weird in the output that you receive, if you don't expect things that are actually there, always tell whoever is responsible for the algorithm. In this case, it will probably be me, because these issues can really backfire in the end, especially when you deal with some critical systems, which we generally don't want to do here at Lively, but you never know what will happen in the future. But always, if you see something weird, just flag it and report it. I think that will bring us to the Ask Me Anything About AI. I just put in this slide to see if you have any running questions, if you have any thoughts. Hit me.
Yeah, I was thinking about the tip 3, collecting as much data.
Yeah.
Is that with the goal just to see, to sort of track where that could have gone wrong, or also to improve the AI with the data?
Yes, that is also, like, improving the AI is one, just seeing if stuff goes wrong, but also to upsell more functionalities, basically.
Because we have data, so we can apply
Exactly,
AI to it.
yeah.
So you should already be doing this, even if you're not using AI at the moment.
I'm looking into getting you guys some tools to start tracking interactions on platforms and stuff like that. I halted it a little bit because it's obviously a lot of work, but I'm working on tooling for you to be able to implement a button that is then automatically tracked. So when a customer clicks on it, you can it is saved, for example. Stuff like that is very important, because then we could offer the customer, for example, AI models that could predict whether they will ever reach that button or reach some kind of location or create an account, stuff like that. And that might be an interesting upsell leader in the pipeline.
Yeah.
So that is an example of always collect as much data as possible.
Yeah. Okay.
I have a question from the chat.
Oh, perfect.
From some guy named Jesse de Vroes. It's a long question. If you would compare machine learning with animal brains, the equivalent of allowing machine learning to explain itself to prevent bias would be humans that can reason. Reasoning is hard for humans too, especially when a decision classification is not purely rational but also instinctive. Does this comparison make sense? Question mark. Would that mean that machine learning is actually the development of machine instinct rather than being fully rational, like programming logistical operators?
Wow, I mean, he has taken the time to write an essay.
I moderated the questions beforehand.
Good. So a machine learning algorithm typically has some kind of going from A to B, and it's one type of problem that you're tackling. So there's just, you have one model to predict something, for example. Meaning that in essence, an algorithm is quite stupid, because everything that is around that decision is not supported, or well, you can try it, but it doesn't really work that way. So the whole, I guess animal brain thing, animals are quite a lot smart. Like the most primal forms of life are probably a lot smarter than an AI algorithm, because it's not generic, you know. You are limited by the data that you put into it, and even if you get diverse data, it is not supported, basically. So yeah, was that, I don't know if that answers the question, but in essence, I would say that the development is going into the way of having these more generic algorithms, where you have multiple problems that you can tackle with just one AI. But we are far away from that, and explainability will be even worse in those models. So it is quite an interesting problem, I would say.
How far do you think we are from general AI?
To be honest, I think we're definitely like 20 years out still. I don't see it happening anytime soon. And even if it happens, I don't think I think it would be in a very like controlled environment. I don't think you can put something out on the street and it works. It's just we are way too far away from that. And right now, the only feasible way to like effectively work with AI is still having a human somewhere along the line to see if what is actually produced is still working, or working the right way. So I think we're very far away still from a general AI.
Any questions in the room?
Yes.
So, some time ago I had access to DALL-E 2.
Mm-hmm.
You may know that, and it's pretty cool. You can fill in some text and it will generate an image that you can explain yourself what you want to see. And I thought that was pretty cool.
Mm-hmm.
What is the coolest thing for you right now that has
I mean, DALL-E is high up there, I would say.
Yeah.
Because there's been a lot of like advancements in like NLP-based systems, so systems that work with natural language, including DALL-E, because that takes in the prompt.
Oh.
We never have a customer call us, except now.
They're watching, now they're calling us to...
Yeah, exactly, just for the questions. Ooh. Nice and corporate here.
But let's forget DALL-E then for a second.
Yes, there's a lot going on with understanding text really well. So in earlier AI systems, there was like, if you had like a short paragraph and you say something in the first sentence, after the second or third sentence, the AI kind of lost track of the running themes. And AI is getting like incredibly good at tracking relevancies throughout longer texts.
I think I have seen another demo that's called Dungeon.ai, I think. And that also kept track of things you said before.
Yeah,
like
exactly.
You could roll, it was kind of Dungeons and Dragons.
Oh,
basically.
yeah.
And it kept track of what you were saying, and it was pretty cool.
Yeah, exactly. So for a long time, like smarter AI never could handle longer documents, which is very, very sad, because the idea is fun, but if you can only apply it to one paragraph, it's not really any feasible thing to get into production. But there's a lot of work going on in making longer texts usable for AI. And that is what I'm really excited about at the moment.
Yeah. But we also did some in Ruler, right?
Yeah, exactly. Yeah. That is again, if it's like a 50-page kind of thing, then my algorithm also doesn't pick up after page like 20 or something like that.
I remember you making an AI of the handbook and giving answers, but it was also pretty limited.
Exactly, it's not that much text, so what was going on. If you want to do that, there's more things you need to take care of, like you could like divide text into topics and then first think like, okay, this question is about which topic, and then go through the text itself. But there's always things you need to work on to get it to work on a bigger text. But now those barriers are actually going away, which is very nice for future use cases.
It's going fast.
Yeah, definitely. Yeah.
I have another question from the chat. Someone called Peer the Meal. When do you think DALL-E will generate APIs and front ends?
I've actually thought of use cases for DALL-E. I mean, I don't know, you probably have seen that like ancient video of having a wireframe and then automatically it's made into like an interface with Bootstrap and stuff like that, so it's completely responsive. And I think we will be going into that direction really quickly too, because in essence these models get publicly available. So you will have this pre-trained model that is very big but has been trained on generating images, and you can just cut off the head of it and train it on layouts, and then you can immediately start using it for specific layout issues. I don't think it will be long until that is actually a thing, but currently these bigger models are proprietary and like kept hidden because we don't know the exact boundaries of the systems, and there's again issues in bias and stuff like that that are unexplored, and that's why they are kept locked behind a nice little paywall with an API instead of access to the model. But I think it will be very soon that we will see AI generating interfaces in a snap.
Thank you. I think that then concludes the questions from the audience.
Nothing? No? Yeah, then I'm done. So I have, if you're interested in these topics, Some of the examples that I've shown in the slides came directly out of this amazing book here on the left. I will share the slides after this session, and because this book is completely on GitHub, so you can just search for it yourself. And yeah, that's it. So we're good.
Thank you.
Oh, can we have one more question from the chat?
Oh, sure.
No, too late.
I'm currently taking an intro to neural network course, and the math is quite involved. The professor mentioned that the algorithm will be pre-built most of the time. Does your day-to-day task involve math, e.g. higher order statistics, linear algebra at all, if at all?
Who is asking that?
I think it's Schouten,
Oh, okay.
but his name is Gurkemerker.
I am aware of the bigger topics, but in a day-to-day kind of activity thing, I don't work with math directly, because the courses that you typically get for neural networks and like making architectures and stuff like that, they are very math heavy, and most of the times you will never look back on them because it's about understanding it for a little bit, but most of the times you just can like take something from the internet and it works like a charm. There's not a lot of times, especially if you take an older neural networks course, where those networks and architectures actually get a better result than something you just get out of the box. That just doesn't happen that much anymore. Is it a waste of time? Definitely not. If every hour that you spend obviously researching AI and machine learning and stuff like that is well used, and it's important to understand the fundamentals. But if you are working on, well, let's just say if you want to add some business value, you will not see a lot of math going on. It's a lot of figuring out what kind of business cases you can work with, and most of the times you don't get that far into the math.
That's a good conclusion. It's not rocket science.
Exactly.
Nice.
Yeah.
Everyone could do it.
I have one more question.
Yeah.
You mentioned AI and machine learning. Is it the same, or is machine learning a type of AI? Or
Yeah, there are these Venn graphs. Wait, maybe I can find one.
I heard if you don't know what you're talking about AI, and if you do, you're talking about machine learning.
Yeah, here we go. So, this is classical example. Oh god, could be better.
Can you zoom in a bit for the people at home? I take my job very serious.
You're a good host.
I can zoom a little bit more. This is clear now, right? So I use the terms interchangeably. It is not necessarily the case because AI is a pretty hefty field with lots of philosophical elements and logics going on, and the research to work with these systems also spans statistics and more classical fields. But when we talk about machine learning, we actually only talk about algorithms that go from A to B or transform data in a certain way, which is not completely everything that AI encompasses, but I use it interchangeably because if I say machine learning and artificial intelligence, it's pretty much the same. And then you also have deep learning here, and there we actually only talk about those neural networks. So we talk about creating architectures that work like actual human brains. While in machine learning you also have a lot of statistical algorithms where you just draw a line between points and that's it. And then you have a prediction for some kind of model. So yeah, that answers the question.
And also from a practical perspective, it might make sense to keep using it AI here because what machine learning N would be.
Yeah, exactly. Yeah. That doesn't work that well, huh? Yeah. No, it's. Most of these things are just buzzwords that sell well. So, I mean, if it works, it works. If it doesn't, it doesn't.
Nice.
Nice. I think we've now finished about 3 times. It's almost like Lord of the Rings. Return to no ending.
Exactly.
But
No
this-
more questions from Twitch?
No.
Perfect. Well,